Hello and welcome to Meet Sector 7. My name is Rinzo and this is part 3 of how to inject Meterpreter into a remote process running on a remote Linux machine without touching disk. In a previous part, we were using self-modifying DD to do that kind of injection. If you haven't seen that part, you can go click here, somewhere in here, and to see what happened there. Now, what I haven't discussed is that one of the problems you might encounter using that technique. So let me show you the configuration and that I don't have any sessions. So let me recreate the problem, okay? So let's run our example from previous part. So we have our session. We can go into it and get bid 2380, 2380. Okay. Now it seems like it works, but not everything works. And let me show what doesn't work. So if we go to shell, interactive shell on the remote machine, and we try to use any command line tools, we get an error like bad file descriptor, okay? And it happens with any tool you try to use. So there is obviously something wrong with our session. So let's try to investigate what happens. And if you can see here, the last command exit was actually successful. So I was able to get back to Meterpreter session. So there is some kind of problem with file descriptors. Let's investigate what is the file descriptor table of our process. So we can investigate with using procfs, and we need to go to fd directory. And here you can see several file descriptors opened, like 0 points to some socket, which is probably our TCP connection. Number 1 is pointing somewhere. It seems like very strange thing, like anonymous inode. File descriptor number 2, which is standard error, points to our console, and there are additional pipes used. And what I can tell you is the problem is here with our standard output descriptor. And why? One of the first things you can find here is that we were not able to get the output from our commands. So there is a write error on one of the file descriptors, and probably it's just a hypothesis, but probably there is problem with standard output descriptor. And being able to exit our shell successfully also might indicate that that's the problem with file descriptor number 1. Now, so let's try to see how DD actually works under the hood. So for that, we will use strace. And let's take some random numbers. So urandom. Output file would be devnull, because we don't need, we don't have to store that information anywhere. And let's just use really just one. So there is a lot of things going on here, but the most important things are actually here in this part. So open@, opens our input file, which is dev_urandom, okay, and returns file descriptor number 3. Then dd calls dup2, which is a system call duplicate. It stores the value of file descriptor number 3 into file descriptor number 0. So now, in other words, dev_urandom becomes our standard input, okay? And then it closes this file descriptor number 3. Then the same goes with our output file. So dev null is being opened. It returns file descriptor number 3, and it duplicates 3 into 1. So in other words, dev null is becoming our standard output, okay? And then it closes number 3. Then it reads from standard input, which now it's our dev_urandom file, some data. Then it tries to write the data into file descriptor number 1, which is now our dev null. And at the end, it closes both, okay, file descriptors. So this is where actually our problem lies. During our Meterpreter shellcode being copied into DD memory, DD actually modifies standard input and standard output. So after our shellcode is called, we don't have these file descriptors anymore. So now we have to find a way to recreate them, okay? So if you go to the blog post and scroll down, Bash delivers you interesting functionality for duplicating file descriptors. So if you use this redirection operator, this is used to duplicate input file descriptors, and if word expands to 1 or more digits, the file descriptor denotes by an n is made to be a copy of that file descriptor. So in other words, any number on that side becomes what is here, okay? And let me give you an example. So let's say we want to list file descriptor table of ls. To do that, we can call ls and point it to a folder or a directory of its own process, okay? So you can see there are actually four file descriptors opened. 0 standard input, standard output, standard error, and 3 is our folder, our directory we are listing. Now, if we do something like this, so we use this redirector operator, we get another file descriptor, which is number 10, and it also points to our sudo terminal session. So how we can use that? We can use that for creating a backup standard input and standard output file descriptors before DD starts, okay? We're using this bash functionality to do that. So in other words, even before DD starts, doing its thing, copying and, changing the file descriptors, making, reading and writing data, we already have in DD file descriptor table 2 backup copies of file descriptor number 0 and number 1, all right? There's another thing we need, which is something which will actually recreate these file descriptors. And for that, we will use really simple shellcode and a duplicate function system call. Let me actually show you what dup function call does. So it duplicates an open file descriptor, okay? And dup function provides alternative interface to the service provided by fcntl function control, okay? Using this command. So let's go and see manual for that. And fdup fd duplicate the file descriptor fd using the lowest numbered available file descriptor greater than or equal to arg. So this command means that file descriptor given here will get duplicated as the lowest number available in the file descriptor table. So let's go back to our shellcode. So this first call will take file descriptor number 10 and create a duplicate as the file descriptor number 0, okay? And the second call will recreate a standard output. So let's go back to our sessions, and I have this shellcode already here, so we can assemble it. Okay. Let me go back to our initial injection. So what we need to do is, before that shellcode, Meterpreter shellcode is called, we need to call our duplicate syscalls, okay? And we also need to create backup copies of standard input and standard output. So let's get back to our MSF console, back sessions. We've got our sessions back. And now if we go to shell, now it all works. To verify, we can go to proc file descriptor. And now you can see that standard output points to the right pseudo terminal. So this is how you can troubleshoot some problems with injection using self-modifying DD and its missing file descriptors. If you like that video, please subscribe to the channel. The link to the blog post you can find down below under the video. So that's it. Thank you for watching and see you next time.